page number 4 of your semester fall semester exam review. Okay. All right. So starting this page is going to be from 16 to 20 on the right side. All right. What is the standard form equation of the line that passes through the point 6, 14 and has a slope of 2 over 3? All right. So couple of key points are standard form equation. Standard form is going to be ax plus by is equal to c. Okay, so that's what we need to make it look like. Well, the problem is we are given a point and we're given a slope. So if you remember from the last page, point slope form is going to be y minus y1 is equal to m times x minus x1. We have to use this equation here because it gives us a point and a slope, so therefore we're using point slope form. Okay, so we're going to write it in this equation and then transform it to look like ax plus by is equal to c. Okay, so let's go ahead and label the x1, which is going to be 6, so that'll be x1, and the 14 will be the y1. Okay, so rewriting this equation, we got y. Make sure you put that minus sign first, then go see what is the y1. In this case, it's 14. That is equal to your m, which is 2 over 3. Remember, m means slope. Times x minus x1, which is 6. Once again, make sure you put your minus sign first, just in case it's negative. It'll basically remind you to do a plus sign. In this case, they're both positive, so they're both going to be a minus, the opposite sign. Okay, so now we're going to take this equation here and we're going to transform it to make it look like standard form. All right. First things first is get rid of this parentheses by distributing the 2/3. Actually, you know what? Back up there. In order to write an equation in standard form, we cannot have a fraction. Okay? So in order to get rid of this fraction, we are going to need to multiply the whole equation by the denominator, which is 3. Okay? So we need to multiply everything. And in my opinion, it's easiest to do it this way, so you don't have to worry about it later. Just get it done, and we're good. So the 3 needs to distribute to the y, the negative 14, the 2/3, and actually it doesn't need to distribute to the inside the parentheses because you're already doing it to the 2/3. All right, so just distributing to 2/3. Okay, so 3 times y is going to give you 3y, and then minus 3 times 14, which is going to be 42. Is equal to, and then when you multiply by 3 and you're dividing by 3, those 3's cancel out, hence we just got rid of the fraction. So now you're left with 2 times x minus 6. All right, and now you're going to go ahead and distribute that 2 inside the parentheses to get rid of that parentheses. Okay, so let's rewrite this up here. We got 3, I'm just going to do it all in black, 3y minus 42 is equal to, now when we distribute that 2 in the parentheses, now we're going to have 2x, and then 2 times negative 6 is going to give you negative 12. All right, and then standard form, you have the x's and the y's on the same side, so let's go ahead and first begin by moving the x to the other side. So we're going to subtract 2x and subtract 2x to the other side. Okay. So on the left side, you cannot combine 3y and minus 2x, so you have to write that as a separate addition subtraction. Since x is first in your model, ax plus by is equal to c, let's put it first in our problem here. So we got minus 2x, or negative 2x plus 3y minus 42 is equal to negative 12. All right, and then the next step is to get rid of this 42. So let's add 42 to both sides. And that is going to give you, on the left side, you still got your negative 2x plus 3y. Now the 42's cancel out, is equal to 42, negative 12 plus 42 is going to give you 30. Basically, it's 42 minus 12 would be another way of looking at that. All right, so almost done. One thing that I haven't touched a lot on in class is in standard form, you cannot have a negative in front of the x term. Okay, so the quickest way to get rid of that is to multiply the whole equation by a negative 1. Okay, or in other words, you're just changing the sign of every single term in there. So the negative 2x becomes a positive, the positive 3y becomes a negative, and the positive 30 becomes a negative as well. All right. So your final answer, ooh, I ran out of room here. So let me draw an arrow up here. And so your final answer will be positive 2x, now minus 3y, is equal to negative 30. And that'll be your final answer there. Okay. All right, perfect. I know that's a lot of work, and there's really not much room to work there, so if you need a separate sheet of paper, please get out a separate sheet of paper so that way it's not really sloppy, kind of like mine is. You want yours really neat, so when you go back and study, it all makes sense to you. All right, number 17. Draw a line that has a 0 slope and passes through the point 5, negative 3. Okay, so a line that has a 0 slope. That is a line that is horizontal, or in other words, it looks like this, right? A line that is vertical is going to have an undefined slope. Okay, so actually let's go ahead and label that. This is horizontal. Horizontal line means a 0 slope. 0 slope. And a vertical line means an undefined slope. Undefined slope. All right, undefined slope. Okay, so it tells us to have a 0 slope. So we want to find the point negative 5, 5 comma negative 3. So if we go over positive 1, 2, 3, 4, 5, and then negative 1, 2, 3, we want to draw a line that is going to pass through there that has a 0 slope. So all you need is that one coordinate, and now you're just going to draw a horizontal line that passes through that coordinate, going all the way across. Okay, so that covers 0 and undefined slope. All right, moving on. What is the graph that models the equation 3x minus 5y is equal to 10? All right, so we want to get our equation in slope-intercept form because that's the easiest way to identify the m and the y or the slope and the y-intercept. So as a reminder, y equals mx plus b. So in order to do that, let me just rewrite this down here because it kind of got messed up. So 3x minus 5y is equal to 10. All right, there's only 2 steps to do. First is to add or subtract the x term. In this case, it is going to be subtracting because we got to do the opposite. All right, so that leaves you with negative 5y is equal to now negative 3x plus 10. Notice how I did not combine the negative 3x and the plus 10 because one has an x and one does not have an x, so they are not like terms. All right, and the second / last step is going to be divide by negative 5 on both sides. And I'm going to put it under both terms, so that way my slope is going to give me that fraction, and it's not going to be one equation with one fraction. I want the slope to be a fraction by itself. All right, so the negative 5's cancel out, so that leaves you with y is equal to negative negative is going to cancel out, so now it turns into a positive 3 over 5 with an x attached to it. And then 10 divided by negative 5 is going to give you negative 2. Okay, good. So now we are good to label our m and our b. Our m is what is connected to the x, so that is going to be 3 over 5, or in other words, our slope, rise over run. And our b is going to be that number that is added or subtracted to the end of the equation. So b is equal to negative 2. And remember, you want to include that sign. If it's positive, then if it's a plus sign, it would be positive, and minus sign would be negative. Okay, so reviewing, going through and graphing your m and your b. First, you start with the b. So what you want to find is negative 2 on your y-axis. So let's go and find negative 2 right here. Let's put a dot there. Good. And then our slope is positive 3 over 5. Okay, so I'm going to go ahead and draw the little kind of staircase for you so you remember what to do. Remember slope, let me write this here real quick, and a little star here. So put a star at the bottom of your graph. M, or your slope, is equal to rise over run. Rise over run. Okay, so we are going to go rise 3, so up 1, 2, 3, because it's a positive direction, and then the run positive 5, so we have to go to the right. 1, 2, 3, 4, 5. Okay, and so you'll notice if I continue to go up and to the right, I'm going to go off of my graph. So we can go the opposite direction of up 3 to the right, 5, and we can go down 1, 2, 3 to the left, 1, 2, 3, 4, and 5. The reason I did that is just so I have more than 2 dots or 2 coordinates to connect a line with, and it's just a little easier to make your graph look nice and neat. Okay, so we're going to go ahead and graph this with a line. Make sure you put arrows on the end to indicate going forever. Okay, so it's not necessary for you to draw those little staircases, those little bubbles, but with your pencil, at least take your pencil and, you know, here I'll give my pointer out. So start here and you just use your pencil and go 1, 2, 3, 1, 2, 3, 4, and 5, just so it may be a little bit easier for you. Okay, so not only did we review transforming to slope-intercept, but we also reviewed how to graph from slope-intercept, locating your slope and your y-intercept. Very good. Okay, so now we have a system of equations, and the good thing about this problem is it is already in slope-intercept form, so we don't need to do anything to change that. All right, what is the graph and solution of the following system of equations? Okay, let's go to, and if you have 2 different colors, this will be a good time to use it. If you only have a pencil, that's fine. It's just a little easier to see with 2 different colors. Remember this, the solution to a system of an equation, that is where the lines intersect. So you can put intersect. The solution is where the lines intersect. All right, so the first equation here, we are going to have the m. I'm going to do this one in red. Okay, so the m is going to be -3/4, and the b is going to be -2. Let me put a line that separates these. All right, so let's go ahead, before we even touch the next equation, let's go ahead and graph this. You're going to graph -2 on your y-axis. Okay, so -2 is right down here. And then this time the slope is -3/4, so going rise over run. Just go ahead and put the negative number. If the whole fraction is negative, just put the top number as a negative. So we're going to go down 1, 2, 3, and then to the right 1, 2, 3, 4. Remember, if you have a negative slope from left to right, it has to go downwards. Okay, so if you have a negative slope and you do rise down, you have to go to the right because you're going negative, positive. If you're going to go the opposite direction, like I'm going to do here, if you go up 1, 2, 3, you went in the positive direction. So now in order to make that slope stay negative, you have to go in the negative direction on your run, which will be to the left. 1, 2, 3, and 4. Okay, and you'll see that I can't really put any more coordinates there unless I go off of my graph. So I'm going to go ahead and draw my line here. And I'm going to do it in red just so I can see the difference between my lines. Might be beneficial too if you guys use a ruler. Okay, use a ruler to graph these. All right, good. And then so I'm going to use a different color to do the other equation. The m here is going to be 4/3, and the b is going to be 1. We will review this later, but you see how the slope of the red line is -3/4, and the blue line is 4/3. These lines are actually going to be perpendicular because you have the opposite reciprocal slope. But like I said, we will review that later on a different sheet. Okay, actually it is going to be number 20. We're going to review that. Okay, so the y-intercept is going to be 1, so go up to 1 on your y-axis and draw a coordinate there. And the slope is +4/3, so we're going to go up 1, 2, 3, 4, to the right 1, 2, 3, because the slope is +positive, so we have to go +positive, or you can go -negative. So we're going to go down 1, 2, 3, to the left 1, 2. Oh, I'm sorry. It is 4/3. We're going to go down 1, 2, 3, 4, and to the left 1, 2, 3. Okay, so this one is not really nice, and I didn't mean to make it like this, but it did, so we just have to deal with it. We are going to draw a line there, and notice how there is not a specific coordinate that these pass through. It's more of an estimation. So I want you to take your pen or pencil and circle where these lines intersect, and I want you to label it. This means the solution. You will not have one like this on your test. There will be an exact point where they intersect, but I do want to remind you the solution is going to be x, y. And when we get to class, I might actually just have you switch a couple of these numbers around so we will have an exact coordinate. But for right now, we'll just go ahead and leave it like that. Just so when you're studying, just remember that the solution to a system of equations is where the lines intersect. Okay. All right, going to the last one. This one won't take very long. Write a pair of equations in slope-intercept form that are parallel and one that is perpendicular. Okay, so just pick any equation. In this one, there's an infinite number of answers. So I want you to label parallel here. And we're going to write two equations. And then I want you to write perpendicular on the other side. Perpendicular. Okay. So parallel, just as a reminder, parallel means same slope. And perpendicular means opposite reciprocal. Opposite running out of room. Reciprocal slope. Okay, so like I said, it might be beneficial for you to use a separate sheet of paper just so you have more room. All right, so parallel equation in slope-intercept form, remember that is y equals mx plus b. Okay, so if you want to write that right above here, that would probably be beneficial. Y equals mx plus b. Okay, so like I said, you can come up with any equation. So let's just, it doesn't really matter to me which one it is. Let's go y is equal to 2x minus 1. Okay, and so when you write a parallel equation to this, a parallel would be y is equal to, the slope has to be the same, 2x, but the y-intercept has to be different or else they will be the same line. So let's just put, I don't know, plus 4, something like that. Okay, it does not, the y-intercepts have to be different, but the slopes have to be the same. Okay, and now the perpendicular equation to this blue line, we're just going to go ahead and to this blue line. A perpendicular one, and it does not have to be anything specific, just something that has the opposite reciprocal slope. So a perpendicular, the m has to be going to be the reciprocal, which would be 1/2, and then the opposite sign, so it'll be negative 1/2. Okay, so just come up with any equation where negative 1/2 is your slope. So y is equal to negative 1/2x, and let's just go ahead and put plus 3. And like I said, it doesn't matter which one you do. All we're worried about is the slope. Okay? All right, this completes page 4 of your fall semester exam review.